Alright guys, here are the notes for the second day of parabolas. For the second day of parabolas, what we're doing is we're focusing on the graphing aspect of the parabolas. For day one, we focused on the equation and making the equation into standard form. This is the standard form for parabolas that open up or down. This is the standard form for parabolas that open sideways, to the left or to the right. So here's one of your parabolas. I'm going to go ahead and label the important parts. Over here at the very bottom of your parabola, that's your vertex. The dashed line that goes right through your vertex is called the axis of symmetry, which we've already talked about before. Inside the parabola is the focus. The line outside your parabola is the directrix. And this little dashed line inside your parabola is called the latus rectum, and that's to be able to determine how wide or how narrow your graph for the parabola is going to be. Now, when you're finding all of these parts, you can use these formulas over here. I would recommend just remembering this formula, which I'm going to put in red, that P equals 1 over 4a. And you are going to use this value of P to be able to find the focus and the directrix without focusing on these formulas. The vertex and the axis of symmetry you should already kind of know how to do. Directions of the opening, again, something you should know how to do. And your formula for the latus rectum is just going to be absolute value of 1 over a. Alright, so let's go ahead and graph one of the parabolas. So your first step is to make sure the equation is in standard form. Change the equation if it's necessary. This is already in standard form because we have our y by itself and we have our quantity squared. So we can first start by figuring out the direction. This parabola is a y equals, which means it's going to be opening up or down. In this case, since my a, the number in front of my parenthesis, is positive, it is going to be opening up. Your vertex is hk. So your x-coordinate, since your x is inside the parenthesis, is going to come with the number inside the parenthesis. But of course, when we're dealing with this parenthesis and you take the number out, you always need to do the opposite. And then since your y is on the outside, your y-coordinate is going to come from the number on the outside. So my vertex is at 2, 3. For the axis of symmetry, your equation for the axis of symmetry, the variable matches what's in the parenthesis. So it's going to be x equals my x-coordinate of the vertex, which is 2. All right, I'm going to go ahead and plot my vertex, 2, 3. I'm going to draw my axis of symmetry. Since it's opening up, your axis of symmetry is going to go up and down. Okay, now whenever you're trying to figure out the focus or the directrix, you need to find the value P. P is 1 over 4a, and a is the number in front of the parenthesis. So in this case, a is 1/4. Now you have a fraction and a fraction, which looks kind of goofy, but go ahead and simplify what's underneath in the denominator first. Makes it a little simpler. So I have 1 over 4 times 1/4 is just 1. So my value of P is going to be 1 unit. What P represents, P is the distance from your focus to your vertex. It is also the distance from your vertex to your directrix. So it's the distance from the vertex to the focus, spelled focus wrong, and vertex to the directrix. Whoops, can't spell. Okay, so we know the distance from my vertex to the focus and the vertex to the directrix is going to be 1 unit. Well, here is my vertex. Since my parabola is opening up, if you recall, your focus is always inside your parabola. So if I'm starting at my vertex and my parabola is opening up, then that means I need to move up p units to figure out where my focus is going to be. Because it's always going to go in the direction of your parabola. So I'm moving up 1 unit, and then that's going to be my focus. Your focus is an actual point. So my point for the focus is going to be at 2 and then 4. Now, since I moved up 1 unit, I'm adding 1 to my vertex, to my y-coordinate of the vertex anyway, since I'm moving up. Your directrix is a line. Now, your axis of symmetry was a vertical line and we had x equals. Your directrix is always perpendicular to your axis of symmetry, so since your axis of symmetry was x equals, your directrix is going to be y equals. And to figure out what the y is going to equal, you're going to go in the other direction from your vertex using p. So instead of going up 1 unit for your focus, we are going to go in the other direction for the directrix. Now notice I didn't plot a point because your directrix is not a point, it's an actual line. So I'm doing a horizontal dashed line 1 unit below my vertex because again that was p. P was 1 unit. So here's my directrix. Okay, now since we have the y equals, to figure out what this is going to equal, you just take a look at your graph and see where it crosses the y-axis. It crosses the y-axis at 2. Oops, let's make that blue. Stay consistent. And another way you can do that is since we started at our vertex, which was at 2, 3, we went up 1 unit for our focus, you're at 2, 4. Now if we go down 1 unit, you're taking your 3 and subtracting 1. Hence the reason why we have y equals 2. Now for your latus rectum, that's going to be absolute value of 1 over a, and that's going to help us figure out how wide or how narrow our parabola is going to be. A in this case is 1/4, so that's going to be the absolute value of 1 over 1/4. Now 1 over 1/4 just means that you're going to take the reciprocal of 1/4. So my latus rectum is going to be 4 units. Now the latus rectum is this entire length going across from your focus. So if this entire length is 4 units, that means in each direction to the left and to the right is 2 units. Your latus rectum always goes through your focus. So from my focus, I am going to go to the right 2 units and to the left 2 units. And that's going to give me the 3 points that I need to be able to draw the parabola. And there is your graph for the first equation. For the second one, we're going to do the same thing. Check to see if it's in standard form. This is in standard form. This one's also opening up because my A is positive. My vertex is going to be -5, 6. Axis of symmetry is going to be x equals -5. So I can go ahead and plot my vertex. I can draw my axis of symmetry. Okay, now for my focus and my directrix, I need to figure out what P is. P is 1 over 4a. A in this case is 1/8. I'm going to go ahead and multiply these two first before I divide. So I have 1 over 4/8 is the same thing as 1/2. So 1 over 1/2 is the same thing as 2. So P in this case is 2 units. I use P to find my focus and my directrix because the distance from my vertex to my focus is what P is, and the distance from my vertex to my directrix is what P is. So my parabola is opening up. So if I move up 2 units, that is going to be where my focus is. Now if I'm moving up, that means I'm changing my y-coordinate. So if I'm moving up 2 units, I'm adding 2 units to my y-coordinate. So my focus is at -5, 8, which makes sense because if you were to actually figure out where this point is by counting your units, it would be at -5, 8. My directrix is perpendicular to my axis of symmetry, so since this is x equals, my directrix is going to be y equals. And then from my vertex, I'm moving down 2 units, and then that is where my directrix is going to be. Now my vertex started at -5, 6, so if I move down 2 units, I'm going to subtract 2 from my y-coordinate. So my equation for my directrix is going to be y equals 4. And you'll see when I actually graph this, it crosses my y-axis at 4. 1, 2, 3, 4. And then to figure out how wide or how narrow my graph is going to be, I need to do the latus rectum, and that's just going to be the reciprocal of A. And it's always positive because we're talking about distance and length. So my latus rectum is going to be 8 units. So that means from my focus, the entire length across is 8 units, which means I need to move 4 units in both directions, always from the focus. 1, 2, 3, 4. 1, 2, 3, 4. I have my 3 points, and then I can go ahead and draw my parabola. So with day 1, we found these 3 pieces of information. For the second day, we're taking these pieces of information and creating the graph, and also incorporating the focus and the directrix. All right. This one, it is in standard form, so we're good with that. This parabola is opening down because this is negative. My vertex is at 2, 4. And my axis of symmetry is going to be x equals 2. I'm going to go ahead and plot my vertex. I'm going to draw my axis of symmetry. Okay, for my focus and my directrix, I need to find P. P is 1 over 4A. A in this case is negative 1/16. So I have 1 over 4 times 1/16 is negative 4/16, which reduces to negative 1/4. And that, when we simplify, gives us negative 4. Our value for P is negative because your parabola is opening down. So in this case, I'm starting at my vertex. Instead of moving up like we did with the other 2 examples, we are going to move down 4 units, and then that is where my focus is going to be. And so since I'm moving down, I'm subtracting my value. So I'm taking my y coordinate and subtracting 4. So my focus is at 2, 0. For my directrix, I'm going in the other direction. And then since I'm moving up, I'm going to add 4, and my directrix is going to be at y equals 8. Which is exactly where it's going to cross the y-axis. And then to figure out how wide or how narrow my parabola is going to be, I'm going to take the absolute value of the reciprocal of A. So that's going to be 16 units. So my latus rectum is 16 units completely across, which means I need to go 8 units in both directions from my focus. It's always through your focus. So I'm going to move 8 units to the right, 8 units to the left, and then I can see how wide my parabola is going to be. Hopefully your parabolas look better than my parabolas. These aren't all that great. All right, another one. This right here is not in standard form, so we need to get it into standard form. What I like to do first is I like to get rid of this 12. So if you notice in front of all of your parentheses, we have a value for A. So I'm going to go ahead and divide both sides by 12 right off the bat. That's going to get rid of this 12 over here. So then I have x plus 6 equals y plus 4 squared divided by 12 is the same thing as 1/12 y plus 4 quantity squared. And I'm pulling out the fraction because if you look at all my other equations, I had the fraction in the front as A. And then to get x by itself, subtract 6 from both sides, and I get 1/12 y plus 4 quantity squared minus 6, because I'm subtracting 6. Now this is in standard form. I can go ahead and find these pieces of information to sketch my graph. Now if you notice, this is an x equals equation, so that means it's sideways. My A is positive, so this is going to be opening to the right. My vertex, please be careful, because your x is on the outside, so I need to take the number that's on the outside. So it's going to be -6, and the number on the outside never changes. My y coordinate, I'm going to take the number from inside the parentheses since it's with the y, and since it's inside the parenthesis, you always want to do the opposite. Axis of symmetry always matches the variable inside the parentheses, so that's going to be y equals -4. I'm going to go ahead and plot my vertex. Go down 4. There's my vertex. Now my axis of symmetry is y equals, and this is a sideways parabola. It's a horizontal parabola, which means my axis of symmetry is horizontal, not vertical like the other ones. And then to figure out my focus and my directrix, I need to solve for p. P is 1 over 4a, which gives me 1 over 4/12, which is the same thing as 1/3. So p in this case is going to be 3 units. So starting at my vertex, I'm going to move to the right 3 units, and then that is where my focus is going to be. Now since I'm moving to the right, I'm changing my x-coordinates of my vertex. So I'm adding 3 to the x-coordinate of my vertex, and that means my focus is at -3, -4, which is exactly where it was when we plotted it. For my directrix, our axis of symmetry was y equals, so my directrix is going to be x equals, and then I'm just going to move 3 in the other direction. And since I'm moving to the left, I'm going to subtract 3 from my vertex of my x-coordinates, and that's going to be at x equals -9. And when we graph it, it should go through -9, which it does on my x-axis. And then from there, I need to figure out how wide or how narrow it's going to be. So the latus rectum is going to be the reciprocal of A, so this is 12 units. So that means going up and down from my focus, I'm going to go 6 units. Now all of the equations that we've had, your parabolas ended up working out nicely on the graph. If you end up with a latus rectum that's a little bit larger and your points for your endpoints for the latus rectum aren't on the graph, it's not the end of the world. Sometimes my numbering's slightly off. But there's your first sideways parabola, and there's probably one more. All right, let's get this by itself. So it's going to be in standard form. I'm going to go ahead and divide both sides by -4. I'm going to bring this out as a fraction, so that cancels. I have x minus 4 equals -1/4 y minus 2 quantity squared. And I still need to get my x by itself, so I'm going to add 4 to both sides. And then plus 4. All right. X equals is going to be sideways. Your A is negative, so this is going to be opening to the left. My vertex, my X is on the outside, so I'm taking the number on the outside. Y is on the inside, so we want to do the opposite. Axis of symmetry is going to be y equals 2. I can go ahead and plot my vertex. Draw my axis of symmetry, which in this case is horizontal because your parabola is horizontal. And then for my focus and directrix, I need to solve for P. A in this case is -1/4. So that gives me 1 over -1 once I actually simplify that, which gives me -1. And it's negative because now we're moving to the left. So from my vertex, I'm going to move 1 unit to the left, and then that's going to be my focus. So moving left and right, I'm changing my x-coordinate, so I'm subtracting 1 from my x-coordinate. So my focus is at 3, 2, which is where we plotted it anyway. My directrix is going to be x equals, since my axis of symmetry was y equals, and then I'm just moving 1 in the other direction. And I'm moving to the right, so that means I need to add 1 to my x-coordinate of my vertex, so it's going to be at x equals 5. Which is where it crossed my x-axis anyway. 1, 2, 3, 4, 5. Latus rectum is going to be 4 units. Now your latus rectum is always positive because we're talking about length. Can't really have a negative length, so it's always absolute value of A. So from my focus, should probably label this as my focus. From my focus, I'm going to go up 2 units and up and down 2 units. Because its entire length across is the latus rectum. And then from there, I can go ahead and draw a sketch of the parabola. That one didn't go through. Let's try this again. There we go. All right, so some key elements of your graph. Start by figuring out the direction, and to do that, you need to solve for A, or figure out if A is positive or negative. Your vertex, that's your H and your K. Axis of symmetry goes through your vertex. For your focus and directrix, you need to figure out what P is. P is the distance from your vertex to your focus. It is also the distance from your vertex to your directrix. And then to figure out how wide or how narrow your graph is going to be, you need to figure out your latus rectum, which is just going to be the absolute value of A. All right, hope this video helped. See you in class.